Look at this sick unit and see how dirty it has become. And due to the dirt, it caused problems. And there's no chance for proper air circulation through its coils. The evaporator is completely blocked, and this side of the evaporator is entirely choked. Then I checked the blower wheel, and it was also 50% choked, reducing its efficiency by half. Since the blower first has to suck air and then discharge it into the room, the dirt had significantly weakened its performance. Everywhere I looked, there was nothing but dirt. In such a unit, water leakage problems can also occur. The outdoor unit was even dirtier, but unfortunately, I couldn't record it. As you can see how dirty the air conditioner was, I'll share a short story about this unit with you. This unit first came to me for repair in 2017. Its outdoor circuit board was damaged at the time, and even then, the unit was extremely dirty. I repaired its circuit board and also cleaned it. The unit was working perfectly fine and was reinstalled by someone else. Now, I went back for its cleaning service. During this period, the owner never got it cleaned, which was a big mistake on their part. The issue with this unit was that its outdoor discharge and suction thermistors had overheated and failed. Before cleaning, I replaced those thermistors, and the unit was functioning perfectly with no issues. I only advised the owner to get the unit serviced regularly. The owner assured me they would call for cleaning service whenever they had time. About 3 to 4 days later, the owner called me for the cleaning. We disassembled the entire unit part by part, thoroughly cleaned it, reassembled it, and reinstalled it. After that, the unit started having problems. The issue was that the unit would run up to 4 amperes and then immediately trip. The owner had installed a digital ammeter indoors to monitor the current, which made it easy for us to see that the unit would reach 4 amperes and then shut off. I then went to the outdoor unit and began checking it with my clamp meter. The same issue persisted. As I mentioned, before cleaning, the unit was working perfectly without any issues and had been running well for 3 to 4 days, making the owner happy. However, after cleaning, when the problem occurred, I thought perhaps a thermistor had failed, become loose, or some wire had gotten disconnected. In inverter mini-split air conditioners, if there's an issue with the electrical supply, a loose connection, or even a minor problem, these units are so efficient that they temporarily stop functioning. The system shuts down once and then restarts the outdoor unit to try again. The unit typically tries to restart itself 2 to 3 times, sometimes even 5 to 10 times, or more in certain cases. It keeps trying to diagnose the issue and adjust until it can function properly. During this process, the unit continues to operate intermittently. Now, our unit was also in this phase, trying to start itself. It attempted 4 times, and while I tolerated those 4 attempts, my patience ran out after that. I decided to thoroughly test the unit to identify the problem. To investigate, we opened the outdoor unit again. We checked all the thermistors thoroughly, and they were all fine. The connections were intact, and no visible issues were present. Then, I suggested connecting a manifold gauge to the unit to check the refrigerant levels. The refrigerant was neither checked before the cleaning nor after, because there was no apparent issue with it earlier, so it wasn't deemed necessary. When we connected the manifold gauge, we discovered that the refrigerant pressure was low, which was the root cause of the problem. This revelation was surprising for us. However, the confusion arose because the unit had been working perfectly fine before the cleaning. The owner was understandably puzzled and said, "My unit was working fine before. There wasn't any problem. How could the refrigerant level drop after cleaning?" This was indeed a question worth pondering. Why was the refrigerant pressure fine before cleaning, but low afterward? And how was the unit running properly despite low refrigerant levels before cleaning? Let me explain the reasons behind this situation in detail and why the unit continued functioning properly despite the refrigerant pressure being low before cleaning. Both indoor and outdoor units have thermistors installed. Some units have 4 thermistors, while most indoor units typically have 2. The unit I was working on had 3 thermistors in the indoor unit and 4 in the outdoor unit. These thermistors are designed to sense different temperatures at specific points, helping the unit monitor the temperature of the pipes. In inverter mini-split air conditioners, certain conditions must be met for the unit to function properly. If these conditions are not fulfilled, the unit will face issues. The first condition is the temperature of the compressor and its discharge pipe, which must be between 70 to 80 degrees Celsius. If the thermistor senses a temperature outside this range, either too low or too high, the unit will shut down to protect itself. The second condition is that the condenser should efficiently cool the refrigerant and convert it back into a liquid. Before the refrigerant enters the capillary tube or expansion valve, its temperature should ideally be between 32 to 35 degrees. If this condition is met, the condenser is functioning correctly. The third condition is that after passing through the expansion valve, the refrigerant must cool further before entering the evaporator. The evaporator usually has 2-3 thermistors installed to ensure that the cold refrigerant is flowing into it and also to monitor the temperature as it flows back. The fourth condition is that the return pipe must also be cold, because a sensor is installed on it to monitor this. When all these conditions are met, the unit delivers optimal performance and works perfectly. In this case, the unit was functioning properly earlier because it was completely blocked with dirt. Due to the blockage, heat was being generated, and the temperature was high enough for the thermistors to detect that the unit was operating correctly. Additionally, the expansion valve was functioning efficiently, and the cold refrigerant was reaching the room as expected. The evaporator, being blocked, caused reduced air circulation, which in turn kept the evaporator cold. This also resulted in the return pipe being cold, so the sensors continued to perceive that everything was functioning properly. After the cleaning, however, the problem started because, as I explained earlier, the unit's various points were no longer achieving the required temperatures due to the low refrigerant level, which wasn't an issue before cleaning. When the condenser was cleaned, the fan expelled heat more efficiently, causing the refrigerant to cool down more, and this led to the thermistors not receiving the expected temperatures at their respective points. As a result, the unit began to malfunction, trying repeatedly to diagnose the issue. Finally, it displayed an error on the screen. This was the reason the unit wasn't working properly after cleaning. In the end, I replaced the refrigerant with a new one, and the unit started functioning normally again. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.